Hi, I am Torey Penrod-Cambra, Chief Communications Officer at HighByte and your moderator for today's panel discussion. I'm excited to be here today for a session we're calling How OPC UA Accelerates UNS. And I'm joined by my colleagues Jeff and Aron, who I will introduce momentarily. But first, let me jump into some housekeeping items. This webcast will be recorded and shared. I know we always get that question, so we'll definitely make it available right after this. And slides and images are also available on request. Feel free to send me an email and I'll follow up with you after the event. Please use the Q&A tools. Our colleagues John and Ty are online and ready to answer your questions. And hopefully we'll also have some time for live questions at the end of the webcast. And I just want to say regarding questions, thank you so much to everyone who submitted questions in advance. You certainly helped shape the content of this webcast. So for the next 55 minutes, we're talking UNS, protocols, strategies to help you scale your digital infrastructure. So I hope you're ready for some great demos. Specifically, we're going to be digging in on the benefits and limitations of common protocols leveraged in the UNS architecture. That includes OPC UA, SQL, REST, MQTT, Sparkplug. We're also going to be discussing how advanced OPC UA connectivity and HighByte Intelligence Hub, including alarms and conditions and structured data, makes data easier to acquire and use in your UNS. We're also going to discuss how to publish valuable manufacturing data from SQL databases to a UNS, spotlighting the new SQL change data capture support in HighByte Intelligence Hub version 3.4. And we'll wrap up with a discussion on DevOps and DataOps. Why are they complementary practices to meet your scale and maintainability requirements? Before I introduce our panelists, I'd like to say a little bit about HighByte and HighByte Intelligence Hub. And to do that, I'm going to ask a poll question first. And that poll question is, how familiar are you with HighByte Intelligence Hub? Maybe use it regularly, use it on occasion. I don't use it, but I'm familiar with it. I've heard about it, or I'm brand new to the Intelligence Hub. It'll just be helpful for myself and for Jeff and Aron to get a sense for how well people know HighByte. Give this a couple more moments. Great, let me max this for everyone. Good. Okay, so a wide variety of responses. Still some coming in. Okay, a lot of people new to HighByte. Great, welcome to the webinar. Happy to have you here. Go back to content. There we go. So who is HighByte? We say we're on a mission to provide manufacturers with the critical data infrastructure they need to navigate digital transformation. And our industrial DataOps platform, HighByte Intelligence Hub, helps us accomplish that mission. Since founding the company in 2018, our customers now span 18 countries and 20 different vertical markets, including life sciences, automotive, pulp and paper, and so many more. So what is HighByte Intelligence Hub? It's a DataOps application built for industrial data and deployed at the edge. You'll see it live today in several demos. The Intelligence Hub delivers modeled, ready-to-use data from any asset or system to the cloud using a codeless interface to speed system integration time and accelerate analytics. With the Intelligence Hub, data engineers can merge machine data, transactional data, time series historical data from a variety of edge data sources into a single payload. They can standardize and contextualize information models in real time. And for me, the exciting part about HighByte Intelligence Hub is really the true collaboration environment for OT and IT. As you'll see, as Aron does demos today within OT, it's the connectivity to OT systems, contextualization, the no-code, low-code interface, and for IT, it includes all of the features IT professionals would expect from other software they're used to using. So containerization, federated architecture, orchestrated from the cloud, advanced administration features, and so on, some of which we'll demonstrate today. So now I'd like to introduce the panelists. Jeffrey Schroeder is a product manager here at HighByte, focused on product positioning, technology partnerships, and reference architectures. He is a wealth of knowledge, and he's an experienced technologist who brings more than a decade in technology leadership roles in the automotive and discrete manufacturing industries to his role at HighByte. So Jeff, thanks for being here today. And Aron Semle is the Chief Technology Officer of HighByte, focused on guiding the company's technology and product strategy through R&D, technical evangelism, and supporting customer success. And Aron has more than 15 years of experience in industrial technology. So we're in for a treat today. We have a lot to cover.
Torey,
so I'm going to jump right in.
Job introing us, then you're going to hand it off, and we're just going to go off the rails.
You're
doing awesome.
Yeah, that's pressure's on. Part of this.
Right.
That's why we compliment one another, Aron.
That's right.
Okay. So first question, and I love this question from Blake. As many of you know, you submitted questions in the registration form. So I love this one, which is, as far as I'm concerned, UNS is just an industry buzzword. It'd be nice to be presented with a case study where UNS has had success, how it differs from other namespaces, or how it is different from relying on traditional data models structured in a database. Additionally, when should a UNS be used? When should it not be used? Blake, I love this. It's like 5 questions. It's a great kickoff, though, to this webcast. And for this, I'm going to hand it over to Jeff.
Thanks, Torey. Yeah, this is a great question. One thing I forgot to, when reviewing these, was the case study. One thing of interest is, I think in the past month, there are at least 2 customers that had video content on UNS-related case studies and architecture. So those have come out or will be coming out shortly. So I encourage everyone to check those out. And special shout out to Matthew Venter and at Gusto and Henrik Bjerk at Siemens Energy. So let me pull up a slide real quick here. So as we all know, UNS, essentially, we've defined this many times, and there's tons of great thought leadership across the internet on this, and we've released materials in the past on there, but at a high level, it's essentially a logical way to structure events. The structure should kind of resemble the way that the business operates, so that might be asset hierarchy. A lot of people like the sort of ISA 95 Part 2 asset hierarchy. That could be by asset type. That could be by use case. It doesn't really matter. The main idea is that users should be able to browse and find data in a way that resembles their business and how they operate. And within that browsing, right, they should be able to receive payloads or values that are relevant for them to consume. If you notice, if you say on the right-hand side there, I think where UNS really quite lends itself to is multiple consumers. It is a full decoupling of producer and consumer of data, right? You know, if you were simply just to take the producer of data and route it to one consumer, right? It's not really not really the true spirit of UNS. I think of the value of UNS comes down to accessibility. It kind of simultaneously democratizes access to data. So in essence, we're not waiting around for certain people to give us data, right? It allows us, it performs an abstraction that doesn't, that decouples it from the producers, but also I think it also provides a degree of governance, right? With the benefits of DataOps, you can govern what payloads look like, have modeled data, and you can even control access to it with brokering technology and so forth. The next thing that I kind of wanted to go in was kind of touch upon why this is so important. Here's kind of a simple practical example. Suppose we were to take a tag out of a PLC, and you know that could be an obscurely named PLC register. Maybe that's called part count. And again, you have to think about industrial automation. It's often set up for process control first and foremost, and it's difficult to life cycle. You know, we could still take that part count value and land that somewhere, but you also have to think of who's the persona consuming that. You know, if this was maybe going into a press, for example, that part count that might be cycles, right? Maybe there's a die set that produces 6 parts per cycle, right? And that means something very different to someone working in charge of tooling versus someone in charge of machine cycles, right? Even if you're an accountant, right, you might want to know, I'm more concerned with cost, so I might actually take that raw value and turn it into some sort of information. Maybe I'm multiplying it times a standard cost. Or maybe I'm a quality professional where maybe I'm looking at ratios of defects and such. So data is very much in the eye of the beholder. And I think this is why UNS is very important, is that it's not strictly, without UNS, it'd be very difficult for a production person to hop around each of those disparate systems and such. I often like to say, if only PLC data is going into a UNS and you still have spreadsheets, it's not truly a UNS. It's just a device namespace, if you will. So the benefit of UNS ultimately is all those different personas don't necessarily have to understand how those underlying systems work, but they have a common place to be able to pull data and collaborate and iterate on use cases.
Thank you, Jeff. And I think that sets up the next question really well too. I think there you just shared a name value pair, maybe from a PLC or from an OPC server, as we start to think about the protocols that support UNS. There's chatter is almost a friendly word. There's a lot of chatter and debate out there around OPC UA versus MQTT. Sometimes gets even a little heated. So Jeff, just to build off of what you were just talking about, what are the benefits and limitations to using these protocols for UNS architectures?
Excellent question. So we'll just go down into the diagrams quickly, right? So I'm just going to kind of go through a couple of different scenarios, right? I think in the essence, really, I think there's a lot of value to both. There's been, some criticism or limitations of the different technologies. There's each strengths and weaknesses. But one thing that I can say resoundingly, I think, seen many customer architectures over the past 12 months or so. OPC is very prevalent, and MQTT is very prevalent, and we tend to see them used at certain sweet spots or where they shine over others. So I'm going to just drill through a couple scenarios and kind of talk, because I think it's a little bit easier to talk about these things in a more practical way, as opposed to kind of the theoretical aspects of what a protocol dictates. So if you think about, if you wanted to go to a pure MQTT route, Sparkplug has a lot of merits. It came out of design sort of for the energy industry. Very efficient over constrained networks and such, just like MQTT has a little bit more payload definition and some state management in it. But if you really think about it, that's a protocol fundamentally designed to take device data and move it up to SCADA layers or perhaps historian layers. So it's very much within the kind of telemetry domain. But as you further go up in the stack and you start dealing with applications or even certain cloud services, like a number of cloud services now have their own kind of MQTT broker or ingest services to basically pull data in. The payloads look less like a variable schema like you might find with or report by exception like you might see with Sparkplug. And you start to see more traditional JSON payloads. The further you go up in the stack, they're more like they're endpoints, right? They're defined payloads. You can't necessarily, for example, you can't report by exception into SAP, if you will, right? It's going to have a defined endpoint with certain with a payload that must be complete. You can't publish things one at a time. One of the strengths that we have seen a lot of benefits with, particularly at the edge, is OPC UA subscriptions, as an example. What's quite nice about this is instead of going directly on the node and having to program, what it's going to publish, at what rate it's going to publish, or dead banding, or whatever, right? You can basically govern your data acquisition from your DataOps infrastructure. And what's quite nice about OPC UA subscriptions, right, is that as the updates happen, they're sort of sent. But what's quite nice about this is that it's governed, right? You can parameterize them. You can basically control the way data is acquired from a central place. So in other words, instead of having your nodes adapt to your data infrastructure adapts to your nodes, right? And we often think that it's much easier to lifecycle DataOps than it is process control nodes that are running critical production and that are very, very sensitive and sometimes resource intensive to engineer. In practice, once people get further down their sort of data journey, if you will, things are a lot more chaotic, right? You start finding that your lab environment doesn't have MQTT or any of your favorite protocol, right? The vendor doesn't really care. It spits out flat text files. Or, for example, maybe it's coming off of a mainframe, or what you're connecting to was never intended to be connected by an external system, and you're essentially circumventing what that application has. You're going directly to a database. And also, again, as the further you go up in the stack, you might be seeing native SDKs, SQL connections, REST APIs, and so forth. So in practice, the world's a lot more complicated than I think we'd all like it to be, and we have to think beyond protocol wars. Something I want to quickly touch upon that's quite relevant, that at least that we've observed with OPC UA adoption, is it does seem like client-server data access, the UA binaries, the classic kind of data that you would see coming out of a Kepware or your favorite SCADA system, that seems to be very predominant in the market. But we have noticed that there are some other features that have taken up an uptick in slight adoption in different corners of the industrial automation market. One area is methods that we're sometimes seeing in the life sciences space, or on very modern PLCs. But two things of note to kind of mention is alarms and conditions, which I'll get to in sort of a second, as well as structured data. So alarms and conditions is essentially the new version of alarms and events, as well as structured data is, kind of going beyond name value pairs and looking at more complex objects. So what I wanted to quickly just touch upon is that OPC UA is still really relevant, despite people being very, very interested in MQTT and such. We see a lot of UNS architectures would not be possible without OPC UA, to be frank, when we look at and practice what the industrial automation landscape looks like and what people actually have in their real life plant environments. And we have a variety of different functionality to be able to support that to get the most out of your different nodes. Most noteworthy in this 3.4 release is that we did recently add support for structured data. So conventionally, people usually think of tags, right, if you will, that come out of PLCs. Maybe they may have created UDTs in the past, but a lot of times once you send that through a gateway or across its native protocol, a lot of times it was broken up into name value pairs. So now we could read structured data, if you will, essentially UDTs in the PLC world, as they're called, and basically surface them as a complex object. The other thing that goes hand in hand with this is we're also starting to notice that there's a trend in the industrial automation market whereby alarming is there's now native alarm instructions directly in PLC environments. So in the past, people may have kind of built their own alarm logic. Maybe they created their own registers and then surfaced those to their HMI or SCADA layer. We're now seeing native alarm instruction sets or native modules. And oftentimes those are being exposed as OPC UA alarms and conditions. One of the issues that we've sort of seen is first of all, obviously alarms are defined very differently by machine builder, which creates some challenges. People want to model that data. There's also challenges getting access to that data. And even frankly, we're even seeing some variations in how maybe alarms and conditions is maybe implemented by the market. So we've built out specific technology that effectively allows users to normalize their alarms.
Awesome. Thank you, Jeff. That was really helpful on OPC UA, and also I feel like you kind of just brokered a peace treaty, perhaps. So very diplomatic of you, and but smart, right? Like grounded in the reality of how people are actually using these protocols in real life. And so with that, Aron, you've gotten off pretty easy so far, but I'm coming for you, and that's because a how question is always best answered with a demo, and that is, how can OPC UA make data easier to acquire and use in my UNS architecture? And with that, I'm going to hand it over to you, Aron.
Excellent. Yep, there's the handoff. Let's see if we can share my screen here.
What could go wrong?
Right. Let me know when you can see it.
You're good.
Excellent. So yeah, I want to show a quick demo. And I know there's a lot of people that are new to HighByte, so I am going to move kind of quick. This won't be like a HighByte 101 or Intelligence Hub 101. But what I want to show in the demo is I'm going to push 3 types of data into the UNS, or data from 3 different sources. I'm going to push data from Kepware, that's traditional OPC tags that we're going to model in HighByte. I'm going to push a structured data type coming from we'll call it a PLC. It's a simulated PLC over OPC UA using the new 3.4 capability. And then I'm going to show you a UDT coming over Sparkplug B. So Sparkplug B calls them templates, but I'm going to show you that and how you can move that into the UNS as well. So to start, I guess the more interesting one, the one that's fairly new, is I've got a simulated OPC UA server here. And if I can pull it up just to kind of show you what's under the hood, I'm using Docker, which if you're not using this yet, it's pretty cool for demos and test environments. So I have a cluster I've spun up that has Postgres, OPC UA, and SQL Server. And for OPC UA, we're actually using this Node.js OPC UA server. If you're interested, we can share more on that. But essentially, that server allows you to program custom types. So when I spin it up, I'll show you inside the configuration, there's this conveyor type. So I'm simulating a conveyor. And if I open that up, this is a lot to throw at you, but this is essentially how OPC UA defines structured data. And there's a lot in here. This is fairly verbose. But if you search through here, You can see my data, the core of my data models down here. So I just have a conveyor type. It's got a name, a speed, a status, and an uptime. And that's really my model definition. And then there's a lot of kind of metadata around it. Now, I did not generate this by hand. I used a tool from Unified Automation. They have a model builder where you kind of visually build this out, and then you can export the XML file, load it into the UA server, and then spin it up. Again, if you're interested in that, we can go into detail kind of after the webinar. But essentially, I'm connected to that OPC UA server, and then when I go in and I browse, we have a branch called custom type branch. These are structured types that are in UA. You can come in here and see all the conveyors. I've imported one already. And it's referenced as a tag, right? So this is just a node. And when I test read it, you'll see this is what comes back. Now, what's different than a traditional tag, an individual tag, is this is a structured type, so it's coming back all the same. And it's report by exception, like Jeff had mentioned. So subscription. So if anything in this changes, the entire structure is sent back over the wire with UA kind of atomically. And if I have it, I might have closed it out just to show in another tool what this looks like. This is UA Expert. If you're not familiar, this is kind of the de facto standard for troubleshooting UA from Unified Automation. It's been around a long time, but let's see if I can do it. I'm just going to connect in real quick. And this is using a self-signed cert, so it's giving me a lot of errors. It doesn't want to connect to the server. It doesn't trust it. But in here, I've got the same conveyor branch. And if I drag this over, you'll see that my view's all... You'll see that there's no value listed. And if you double click the value, you can see it's a conveyor type, and this is the data. So this means it's a structured type over UA is all I wanted to show there. So this is, once it's in HighByte, you don't really care, right? This looks like any other data type. So let me jump off and we'll look at the Kepware, direct Kepware tags, kind of pulling this together, and then the UDT, and then we'll come back to this one. So in Kepware, this is the traditional approach, right? I've got a device PLC set up. I've nicely named the tags, uptime, status, and speed. I have a connection to Kepware over OPC UA, and in here I browse to the conveyors. As you can see, browse down, and I've imported that conveyors list. In here, if I do a test read of the branch, there's no branch read in UA, so we're kind of doing this on the user's behalf where we browse and read this data in, but you can see there's the data that's coming through. But this is not modeled, right? These are individual tags that we're getting over a subscription, which means we need to model it. So in HighByte, what we've done is created a conveyor model. It's got the attributes I care about: speed, status, and uptime. And then what I have is I have an instance of that conveyor, and I've just called it conveyor UA. And what I've done is I've gone in and mapped that out. Oops, it's Kepware. So I've used our reference browser here to go find that input. Then I've just kind of dragged and dropped those references. No JavaScript, no need to manipulate that data. And then when I do a test read, I get a very similar modeled structure, right? But this is being pulled together from individual tags. It's not using a struct from the PLC. The last one I want to show you before I flow this into the UNS is the Sparkplug example. So over here, I've got Ignition Designer. You'll see a common theme, right? I've got a model defined as a UDT. And wouldn't it be nice if all these models you could generate in one place and send them out to the different sources? More of that's coming 4.0 stuff we're working on. But UDT definition in Ignition, speed, status, uptime. And then I've got a tag defined. I've defined an instance of this called conveyor Sparkplug B, and I filled it in with tag data. So Ignition has this. It's simulating data. And then what I've done in Ignition, let's log back in, is I've set up the transmitter. And you might have to come back and watch this. I'm moving fast. But in here, I have a transmitter that's transmitting that branch over Sparkplug B. So I'm transmitting that Sparkplug Portland branch out. And in HighByte, what that means is if I create an Ignition or Sparkplug B connection, I'm going to connect to our local broker. So this is 1885. So for folks that don't know, HighByte can host a broker internally. It can also talk with Hive or MQX or any broker you want to use. But if you need a quick solution, you could turn on the broker here on port 1885. So I've got that on connected. I've created an input that just says, listen to everything that's coming over Sparkplug. So if I do a test read on this, you'll see I'm pulling in this is the group and edge node ID, but there's that conveyor Sparkplug model, and it looks the same. You can't tell from the JSON that there's actually the data structure behind this that we have as well. That's the data definition, but it's there. This is just the read result. So now what I want to do is flow that to my UNS. So what I'm going to do is launch our UNS client, so we can kind of see this as we build out. So this is going to connect to that broker. And you're going to see the Sparkplug data that Ignition's publishing in Sparkplug format, but we can just kind of ignore that for now. What I'll do is create a flow that says conveyors to UNS. So I'm going to take the 3 references. So I've got the Kepware data that I pulled together and modeled in HighByte. I've got the direct struct coming from the PLC. And then I've got the Ignition conveyor as well. And I'm just going to send that all out to a common topic, Portland packaging line. And then I'm just going to substitute in the names. That would be conveyor UA, conveyor Sparkplug, etc. So I'm going to turn that on. And then when we get out to here, we'll see that it'll quickly show up in the namespace. I've got Portland packaging line. I've got conveyor UA. So this is the one that's coming from Kepware that we're modeling the discrete tags in HighByte. This is the one that's coming directly from the PLC. It's a structured data type. This is the one that's coming from a UDT from Ignition, transmitted over Sparkplug B templates. The whole point of this is, if I didn't label these, you couldn't tell the difference, right? UNS provides that abstraction layer. They're all a common definition of the data model. That model happens to be coming from different systems, but by the time it comes through HighByte, it all looks the same. So when I'm in the UNS, I see the conveyor information, and I don't care where the source came. It kind of plays into Jeff's message of you kind of have to use what's there. You know, don't go rip and replace everything with Sparkplug day one, et cetera. And there's pros and cons to each of these, which Jeff had mentioned, and we can go into more detail. But I wanted to show that example. By the time it gets to the UNS, you don't want to know where it came from, but you need the flexibility to pull it from whatever source it's coming from.
Aaron, that was pretty slick. That
Yeah,
was
pretty
actually
cool.
my first time seeing this demo as well.
Me too, actually, right? It really came together.
Nice. Okay, so I'm going to do a quick poll and into some other questions. So the poll question is, other than telemetry data, what other data is useful in your UNS? And we have some options. Your asset maintenance data, files, MES data, product information or scheduling information from your ERP, perhaps quality data, or the elusive other. Let's see here. All right, I'm watching some good responses come in. Right now, MES is narrowly the winner. Awesome. Okay, I'm gonna continue to let this go, but I'm gonna minimize it. And then when I close the poll, the results will be available in the polls tab. So let me jump back in to the presentation. Okay, next question. So hang with me here. These are 3 questions and they sort of seem unrelated, but there is a common theme, and I'm gonna hand it to Jeff to answer that question in a second. And MQTT and Sparkplug came frequently, and there were questions of, can HighByte Intelligence Hub transform OPC UA data into UNS or Sparkplug B format if there's no UNS broker directly available before the data reaches HighByte Intelligence Hub? Also a question around round-trip latency with on-premises systems like SCADA, PLC, et cetera. And then another question on best practices for moving image and video files through the UNS. Can that be done with MQTT? So there's a variety of questions, but I think it gets to the heart of best practices for UNS. And so I'm going to hand it to Jeff to answer these questions.
Got some challenging ones here. So I think the first question was kind of around, hey, is HighByte dependent on a broker before it can pick up data? Of course not. HighByte can coexist with non-broker architectures or non-UNSs. We have a number of customers who maybe only move data from historians and move it into the cloud, for example, and there's no brokering in between. But I think but one of the things in that question was something regarding saying, hey, can it convert OPC UA to Sparkplug or to UNS format? We're kind of more or less implying that UNS format is strictly Sparkplug. Again, Sparkplug is primarily a device level protocol. It was sort of very, very efficient at taking a device level namespace and telling a SCADA system or a consumer of a broker on the other end or an IoT platform or a historian, here's what the schema looks like, and now I'm going to only publish the updates, right? And it provides some state management and clever tools on there. We do find though, is earlier I'd mentioned, UNS is about accessibility, I think, and it's about a degree of abstraction away from underlying source systems. It makes data accessible without people having to be a domain expert or a system owner, if you will, of where data came from. It's also about a degree of governance, so that we're publishing consistently across all of our lines and sites and so forth. So I think as a device level publish, it's okay, I think, Sparkplug to use as sort of a device level namespace, but in practice, when you start expanding out, when you have other types of nodes that maybe need more traditional JSON payloads, if you will, or you need more browsability, it makes a lot of sense in many cases to stick with good old MQTT JSON for a UNS. Again, just like we sort of implied earlier, life gets a little bit more complicated, right? In some cases, you might have nodes that are OPC UA, and subscriptions are a good place to do that. Sparkplug is, again, another sort of alternative that might live quite well at the edge. We generally find, though, is that when you start building up a more sophisticated UNS where you need that level of browsability, you want to curate payloads for consumption, right? Ultimately, the consumption is probably more important than the merits of any protocol and also the performance of them, right? The main idea is that business users, applications, services and such should be able to get access to data as efficiently as possible. So we generally see, kind of the higher you go up in the stack, the further and further you'll go through what I'd kind of say is device style protocols such as Sparkplug and OPC UA. The next question was kind of regarding latency, right? And I think this goes on to supervisory control, or I think there's a question regarding pressing a button, right, and saying, hey, there's this round trip latency from the moment someone presses a button on the HMI or SCADA display, and has to traverse a broker, and that's traversing a protocol gateway, and then going to a native protocol and to a comm server and all that type of stuff. When we see scenarios like that, sometimes we sort of say, hey, are you doing control just because the broker's convenient, or is it a slow moving process, right? I could understand maybe if it's midstream oil and gas, right? And it's a heavily supervised process. Human beings are watching every valve open and close. Events only happen, every half an hour to an hour, right? That could be a scenario, but in practice, SCADA is really a process control domain. And I think SCADAs have sort of evolved where sometimes they're used as IoT platforms, sometimes they're used as more traditional SCADAs. But I think there's a lot of still good merit actually using things like OPC UA or even the native device drivers in many cases, if you need that kind of maximum performance between to do, like, say, HMI or command type workloads. That can still, of course, exist with a UNS, right, for consumption. But as far as kind of command or control or supervising automation, right, maybe it makes sense to kind of couple your process control nodes together. The next one was regarding sort of image and video files. And this has obviously been proven in the market before. People have, or proven by the spec, if you will. MQTT is a standard, right? You can ship off a binary into a topic, and that can certainly work. The bigger question, though, is what clients effectively sort of consume that on the market. Generally, when at least that our customers and system integrators and other technology partners generally see, when people are referring to MQTT, generally they're referring to a JSON payload going over MQTT, or JSON encoded through protobuf, if you will. So you could obviously set a vision across it, but it creates this kind of complicated scenarios, right? Is there an image client that would know how to say, what if an image file is larger than the standard MQTT topic size, right? Is an image client going to know how to kind of iterate through that, or how do you kind of handle that? It gets quite messy. And so this is another scenario where I think discrete connections do have a place, right? We do have customers that connect to vision systems and files, right? And they can kind of pass those on to on-prem targets. Meanwhile, as they acquire unstructured data, they can also acquire structured data about its context, right? So let's suppose that we took images off of a vision system, right? We could take the events that happened, maybe what was the serial number, or what was the sequence that was sort of operating at, or the lot of material, right? And this is where I think discrete connections, or being able to route unstructured and structured data separately, has a lot of merits, right? We could take data and maybe shift that off into the unstructured data, the image files, going into something like S3, and now we have a record of all of our product produced. But maybe the structured data, maybe we want to land that into a database services, as a database service such as Aurora, as an example. And the benefit of something like this, right, is as opposed to having this kind of awkward pub sub paradigm for unstructured data, you kind of wouldn't want to subscribe to images of blobs being sent at you. You now could maybe create an application sitting on top of a database, right? And you could say, I'm going to look up all the products shipped to a specific customer, and now I could click or open up an object, and that could then present an image coming out of an object storage service, such as S3, right? So I think, well, UNS has a lot of benefits for kind of democratizing and governance of structured data, right? I think there's still a lot of scenarios that you'll find that where discrete connections do have are optimal and inappropriate in many cases.
Thank you, Jeff. Very helpful. And I hope that addressed everyone's questions, which actually your description using diagrams takes me really well into the next question, which came from Brandon. How should different types of data be published? You covered some of those, Jeff. And now I think it would be helpful for Aron to show this within HighByte Intelligence Hub. So Aron, I'm gonna let you field this question, please.
Awesome. With a demo, do I get to do another demo?
Yep, you're back up.
All right, let me know.
Looking good.
Can you see? Oh, the license expired. So this is the new experience of 3.4 as well. So actually I didn't time that. This is perfect. So this is what happens. You get logged out after the 2-hour demo and you just go like this and you don't have to talk to sales. You're back in it. So this is new. This is the new trial version in 3.4, just so you can see how it works. When the license does expire,
you're such an engineer, Aron.
Right, all flows and everything shut down. But once you reset, everything starts working again. Yeah, so what I want to show, we'll focus on SQL data specifically because we have a new feature in 3.4, change data capture, which if you're not aware, it's a more efficient way to capture changes to a table. Those are inserts, updates, deletes, than just polling the table consistently. The challenge is it's different depending on the SQL technology you're using. I'll show you SQL Server. We implemented it for Postgres as well. I won't demo that as part of this, but each one does it differently under the hood. It's the same kind of end result though. So to start that really quick, I'm going to lead into some of what Jeff was saying around alarms and events. So I'll show a quick demo of that. I'll use that to generate the test data for CDC. So in that mock UA server, the simulated PLC I mentioned, it also supports events. So if you browse through here, you can see there's an event type branch with some nodes that produce events every second, and then one that's a condition-based event based on a tank level. So I've imported these in. You can see in here, there's a new event type. So events are supported in UA. It's another part of the specification, alarms and events. So this is report by exception. Basically, when this event gets generated, which this will happen every second. So we should see, if I just expand this, if we do a test read on here, about every second, we should see this timestamp update. This is just shooting a basic event out. An event in UA is nothing more than a collection of attributes with a value, right? And these are the default, what I would call the default attributes. So you can filter to further specify and restrict or enhance what you want to collect. But by default, if there's no filter, this is what you get. Just to show you how it works, if I hit find, I can browse the UA server. It'll show me all the different event types it has and the attributes that are available. If I pull one in, this is only going to give me back the event ID. So if I do a test read there, you'll see only the event ID comes back. That's not super useful, but just as an example, you can pull that. So the other one is a condition-based event. So this is a tank level that's in the OPC UA server. And if I do a test read there, it's going to time out. All right. I have to go generate the event. So I have an output to go right to that tank level. So let me just write a value. There we go. And you'll see in the message 500 was written. So that when I was reading, there was no event that was generated. It's all report by exception. So it was just waiting to see if an event occurred. I went and created an event, and you can see this one's similar to the other one, but it has 2 additional attributes that include the condition name and retain. So what's important about this is what we've seen adoption of events in PLCs and over UA more than we have structured data. Like structured data is definitely increasing, but events are much more common for people to program those in the PLC. And what that means is the challenge you'll have is that those events aren't going to be consistent. Like people will create their own event types or their own attributes, and you'll end up with this, this PLC produces events in this shape and this one produces events in this shape. So it's a modeling problem, right? We're very familiar with that at HighByte. So what I've done is I've gone in and created a PLC event model. I've decided, hey, I just want the source message and time from the event very simply. And then I have 2 instances that pull from those 2 inputs that I had shown you. where what I've done is I've just mapped out, for the raw PLC events, I've mapped in the data. And then likewise for the condition-based event, I've mapped in the condition data. And what it means is upstream, I'm not going to care. The events are going to look the same, right? So I can kind of harmonize those events through a model. And what I'm going to do is I'm just going to take those events. I'm going to read both of them, and I could do this off a change, like an exception-based change, but I'm just going to pull them and use an on-change filter. And I'm going to write them out to SQL into an events table. So I'll turn this flow on. And this is going to send the PLC events direct to a SQL database. And if I go back out and look at that SQL database, and that's running inside of Docker. So that is this one right here. So if I go in and I read that, I'll just have an events query. So I'm saying, give me the top 5 from that events table. And you'll see the data comes back in the event shape with, ID is the incremented, the auto incremented column. And then that's the metadata we add. And then there's the source data from the model. So now I have data, every second at least I'm having an event that's is getting dumped into that SQL database. So what I want to do is monitor that database, find the changes, and report that out. So that's the new feature in 3.4. So in the SQL Server connection, what I have is I have another input that's a CDC input. So it's monitoring the same table, but it's set, instead of a query-based thing, it's a change data capture. And this is just a limit on if there were 10,000 changes, it would pull back 100 at a time kind of deal. So you can kind of limit or throttle that. And if I do a test read on this, what you'll see is that the shape is different, right? The shape is all the data and metadata that occurred in the event. So you can see the tables in there. And if I were to implement this in Postgres and go do the same thing, this shape would be the same, right? So this shape is consistent, or we've made it consistent across database types. You can see the schema, the table name, the operation was an insert, it generated this primary key, and then here's the data that was inserted. Now the test read is just going to show me the latest state, like all the cache changes. If I hook this up to a flow, it's only going to process each individual change once. And that's because there's an index that gets updated, and you can clear that out to go re-request changes, etc. But this is the change data. So what I'm going to do is I'm going to go into a flow, and I'm going to take a flow that takes the SQL changes and sends that to UNS. I think the important part here with respect to UNS is common flows from SQL to UNS are, hey, go grab, do some kind of average or join or top row kind of calculation in SQL and publish that to UNS. Or, if you just want to detect changes in a table and publish it to UNS, this is a good approach to do that. It's more efficient than polling and indexing. And I'll show you how it works. So I'm going to turn this on. This is going to grab those change data captured events, and it's going to send it to a pipeline. And once I turn it on, I'll jump into the pipeline to show you what I have configured here. Let me zoom out a little bit. So in the pipeline, the events are coming in. That's the events since the last, any change events that occurred since the last execution. The first thing I'm doing is breaking it up because it's an array of changes, and I just want to process one at a time. After that, I use this new switch stage that's in 3.4. So this allows you to kind of branch off of a condition. So you can see one is an insert and one is an update. So I can look in that data set and say, hey, if the operation was an insert, I'm going to go down this path. If it's an update, I'm going to go down the other path. I could implement a delete as well. I didn't do that in this example. And then I'm just going to grab a piece of the data. In the insert case, I just care about the after, which is the value that was inserted. In the update case, I'm going to go grab the before and after because I want to see both. And then in terms of the UNS, I'm very simply just going to push that out in an events topic on the insert side and then events update. So if I jump to my UNS, which I got kicked out when the timer went off, we'll jump back in. We'll see. And there is a 5-second delay. So SQL's weird. You can go and configure how fast internally it's going to pull the table. So although I'm generating an event every second, SQL is only going to pick that up and send me 5 at a time. So if you monitor the timestamp here, you'd see it's about 5 every 5 seconds. It increments, and then you'll see this number jump about 5. But you can see this is the insert, right? This is the data that was inserted into the row. And in this case, all 5 updates are being sent to MQTT. But since MQTT is only going to show you the latest value, they happen so fast you don't see all 5 of them. So the last piece, I'm just going to go in, and this is the events table. I'm just using SQL Management Studio to go look at it. I'm going to cause an edit event. So I'm just going to go into this table and cause an edit. And within 5 seconds, we should see an events update show up. Fingers crossed, 5 seconds is a long time. And you'll see this is the before and this is the after, right? And you can see the edit that occurred. Now, I'm not doing any modeling of this data. You probably wouldn't push this raw format into your UNS, right? You'd probably go model it or massage it a little better. But this is just an example of I can take change data, UNS is report by exception. I have an easy way to integrate those things efficiently without constantly polling the database. This is my favorite feature in 3.4. If you got the UNS client up and you try to navigate off, we ask you if you want to, because I so commonly would navigate off and then have to fire it up again. But back to you, Torey.
Awesome. Thank you, Aron. Really nice job on that. And I have to commend you on your absolute bravery for live demos. Brave man. Okay, so next question. Jeff, I'm going to take this one to you. Just a couple minutes on this one, because I still have one more demo I really want us to get to and a wrap-up question. And so this is regarding UNS, and I'm guessing you're going to end up talking about DataOps too. Just how can I ingest data from manufacturing lines to AWS S3, Amazon S3, without implementing an MQTT broker or similar pub sub services? Jeff, you want to take this one?
Fantastic question. So S3, as we all know, it's an object storage service. It's probably the most mature AWS service that they have. I often kind of joke that it's the internet's hard drive in a way. Oftentimes when you go to a website, you know, it's often serving up the images in many cases. Since Aron just demoed SQL Server, CDC will do this as a particular scenario to maybe represent a manufacturing line, but this could really essentially be any data. And this is actually a very common scenario among some of our customers, where they have very complex or high-speed manufacturing processes, and their MES generates a lot of events. And it's not just generating a lot of events, but they also have a lot of modified or late arriving data in their MES database. And these are MES environments that generally need to be on-prem. They can't really afford to have that. It definitely needs to be localized, but a lot of times for analytic purposes, there's a huge desire to effectively normalize all that data and have it in one place in the cloud so they can do kind of cross-site benchmarking and more sophisticated analysis. So a common approach that might be done is, you know, sometimes it's too hard where some MES systems don't really have like a subscription, if you will, to get change data out. So a lot of times going directly to the database and doing change data capture is a very efficient way of doing that. You know, a lot of what I think one of the things that with UNS that's I think has been a challenge is a lot of times when people first are reading about, they're like, oh, that's great. I can plug everything into this hub in the center of my factory, and I don't really have to worry about these discrete connections anymore, or I can all just integrate everything in one place. And I think there's some merit to that, but a lot of times there's some exceptions, right? MQTT is primarily concerned with current state. It's brokering events. It has certain payload sizes. So a lot of times for scenarios like this, where maybe if you needed to move, I don't know, on average 80,000 rows of SQL MES data per day, or you need to move 10 years of historian data, it probably wouldn't make sense to move that through a broker, right? And so this is a great scenario for DataOps where you don't necessarily need a broker. So in this scenario, right, we could take data, do change data capture directly on the edge. So we're not moving more data or slamming the database harder than we would normally need to. We could take those events and buffer them and land them into an S3 bucket. And so in order to be a contrarian here, because I often enjoy kind of challenging questions, I know this question specifically said, do I need a broker? But I'm going to show a scenario where a broker would be potentially relevant. So suppose that we're landing data in bulk into S3, and maybe we're using Snowflake, we're doing the Snowpark libraries or the tasks. So essentially we're calculating KPIs down there. Suppose we wanted to take that data back down to maybe, we don't want it to be stuck in the business intelligence layer. We wanted to move that data to an Andon display or an HMI or a SCADA screen, right? This could be a scenario where a UNS or a broker may make sense, right? So we could execute queries directly on the Snowflake environment and then push those values back down to the edge if we needed to. So this is a good place where historical data doesn't necessarily, the raw historical data that should probably not live in the broker, but however, maybe snapshots of it or calculations of historical data definitely have their place within the UNS.
Perfect. Thank you, Jeff. All right, I am going to jump back into the questions. Okay, these aren't really questions. I get that, but these keywords showed up in lots of questions. Master data management, data integrity, And without further ado, I think this is going to be our last demo today. Aron, can you talk to us a little bit about complementary nature of DataOps and DevOps? And I'll hand it back over to you one last time.
Yeah, no problem. Let me watch. I got to do it one more time. I'll mess it up this last time just for kicks. Yeah, so I'm going to focus more on the DevOps piece of that question. I think the whole like master data management in terms of modeling, I saw a question in the chat around, how do you synchronize the model between the UDT definition and ignition, the data type and the PLC over the XML type that UA requires, and then HighByte. I think that those are interesting discussions and things we're thinking about around 4.0. But we'll save that one. So I'll focus more on the data ops and a change that we made, or DevOps and data ops, a change we made in 3.4 that I think is fairly relevant and helpful with deployment. So then this is really around how you manage dev QA production environments, and specifically secrets and passwords. So one of the things we did in 3.4 is, and I'll just show it quickly in the UI. So you can see this is my SQL connection that's connected into this Docker container. It has a password, right, that I set up when I spun up the Docker container. And you can see it says using system secret MS SQL password. And if I jump over and I look at the Postgres variant, which I didn't demo this, but I had it set up, it says encrypted and saved in project. So what we did is in 3.4, we decoupled the password saving from the project file. And what that actually looks like in practice is, if you're not familiar, this is the Intelligence Hub configuration file. So everything you see that I've configured is in this file in a JSON format, can be edited, reloaded, etc. This is my SQL connection. And when you see, if you come down in here, when you get to the settings and specifically the password, it's a reference to this thing called SQL Server password. And if you come out, there's a new file that if you use this mode, it's called Intelligence Hub Secrets. And if you open this up, you'll see that the SQL password is in there. It's an encrypted, but it's separate from the project, right? And if you look at the Postgres one, oops, go back to the main config file. The Postgres one, which did not say that, it was a little different, has that password actually encrypted in the configuration file. So what this means is, if you move the project file around, the password's embedded in there, and if you move between environments, that password has to be the same. That's not very common in dev production and QA environments. So what we did is you can offload that into that settings, that secrets file, and just replace that secrets file in order to move between your environments. And in the actual UI, what that looks like is this. So we had system variables before that allow you to change IP addresses and other things in the connection. Now we have secrets, so you're able to kind of enter that secret here, encrypt it, it saves it in that separate file. It can be different per environments. And then potentially this is the only file, that secrets file is the only thing you need to change as you switch between environments. There's one other thing I did want to show actually that kind of flows into this. I missed it in the first demo. This is what happens when you don't when you don't practice. We got just 2 minutes, I'll show. So the conveyor to UNS demo, I had another pipeline configured that has a new feature, and it does have to do with data integrity. So I have a 2 clouds. So this is the conveyors I was gathering from UA, Sparkplug, and the OPC tags from Kepware. So in addition to sending out to the UNS, I'm also going to send it to this pipeline. And if you go and look at this pipeline, what it's doing is it's writing out to different sources, but depending on failures now, you can take different paths. So this is writing to Snowflake. So it's writing out to a conveyors topic or table in Snowflake. And if you look at the replay in here, everything's, life's good. The conveyor comes in, it takes about 15 milliseconds to write, and then we're done and everything looks good. And if we go out to Snowflake and I were to query that table, you can see the conveyor data is all modeled, nice and pretty, everything looks great. But let's just go cause, I do want to leave this time, but let's go cause an error. So what I'm going to do is go into Snowflake and I'm going to mess up the configuration. And what you're going to see is if I refresh and look at some of the more replays, let's exit replay. Something had to go wrong. There we go. I think it was just a delay. So now it's failing the Snowflake write, right? It tries and attempts. There's a failure because I messed up the connection settings, and now it's sending it to BigQuery. The BigQuery writes are taking a little longer, but if we went into BigQuery and this is a new connection type we have in 3.4, you can see the same schema, same data is now landing in BigQuery as a failure path. Now, just to take the chaos just a little bit farther, right? If I go in and ultimately mess up the BigQuery settings as well, you'll see that pipeline is eventually going to start to fail. So we took the failure path down, took the failure path away. So it's a long way of saying we now have, success failure paths for writes in pipelines. That does give you some control over if there's a write failure, data integrity issue, et cetera. You can now kind of control the path. And there's a ton more we're doing in 4.0, more on that to come around data integrity and managing models and validating models and pipelines and that kind of thing. But I'll leave that as a teaser.
Love that. Thanks, Aron. I like that you just had a hard time making a mistake.
Yeah.
That's a good demo. I'm impressed. Okay, just a last couple here. And I know we're at the hour, but in 30 seconds, this one, what's best approach to UNS when starting with a large system, many operations, integrated services? Better to plan long-term, or is it better in the long term to plan to migrate away to another solution, or stay in the space and leverage what you've got? Jeff, 30 seconds.
Excellent question. I would say you really don't know what your future is going to be until you get started, right? Each step that you take, the next steps become clear along the way. And I would say, in terms of making industrial automation investments, if you're going from Industry 2.0 to Industry 3.0, that can make a lot of sense. If you're barely at Industry 3.0, maybe that sort of makes sense. But if you already have kind of good, sufficient automation that's in place, ripping and replacing is probably not a viable option, because a lot of these things like UNS and Sparkplug and all these things and Snowflake, these things didn't exist that well 10 years ago, right? So you can only imagine, does it make sense to replace something that's 30 years old now? Who knows what's going to happen in 10 years from now? So I'd say use what you have and be use case driven.
Perfect. Thank you. And Aron, since you just set up this question so perfectly earlier, I'm going to ask you anything that users need to consider or preliminary work they should do before trying HighByte Intelligence Hub?
Absolutely not. No, just go get it and kick the tires on it. Yeah.
Perfect.
And then reach out if you have questions, but yeah. Yep.
Perfect. Yeah, we'll send out a link after this. Obviously, you'll get the recording and some other resources related to HighByte Intelligence Hub version 3.4. We'll also send out a link with the link to the trial program. So if you haven't tried HighByte Intelligence Hub, you can get access to it today if you want to. So thank you all so much for coming. A huge thanks to Jeff and Aron who make these sessions possible. Really appreciate all of the time and thought you put into this. So thank you so much, and see you at the next office hours.
Cheers. Thanks, Torey.
Thanks.